All right. Hello, everyone. Hope you all had a great weekend. Yeah, we're kind of at a sort of a turning point here in this class. We have 2 weeks left until spring break. Next week, we're going to be talking all about the project. So I know I've been kind of hinting at the project all semester long. It's coming, and we're going to spend a lot of time talking about it next week. Still nothing you really need to worry about right now as far as the project goes. I still want you to focus on getting those 5 assignments finished. So that's where your energy should be going for this class for the time being. There's one more left that I'm going to talk to you about today to kind of wrap up the first section of the course. But starting next week, we're going to shift into project mode. One other thing I wanted to make you aware of, scheduling-wise, kind of looking into the future, just so that you can plan. This is spring break right here. There's obviously no classes there, but I'm actually going to be out of town for a conference the week after spring break, so I physically will not be here on the 18th and the 20th of March, so you physically don't have to be here either. Those will be work days for the project, which will make more sense once we start the project, but yeah, just wanted to make you aware that I will be out of town on those 2 days so that you can start planning accordingly as well. We'll talk about assignment 5 later. Assignment 4 is due today. I've spoken with a few people about it. Seems like it's going okay, but if it's not going okay, please let me know. I know it feels a little bit different. I have finished grading assignment 2, started grading assignment 3, but I'm not done grading assignment 3 yet. But that's one of my goals for this week, and then obviously starting on grading assignment 4 after that. I'm hoping to have everything, graded and mostly up to date by the time we get to spring break. Fingers crossed. So, all right. Let's talk about objects. This is our final unit on clean coding. So we've spent the last 3 class periods talking about code quality, what it means to have code that's of good quality, not just code that's functional. We spent a lot of time looking at code, rewriting code to make it look better, and we're going to do some more of that today as well. Today with our big focus being on objects. And so before we dive in and talk about how to rewrite some code, I am going to look at the DICE exercise that we've been working on the last 3 class periods and insert some objects into it. But before we talk about that, let's talk about some general rules that we're going to try to keep in mind in our code when working with objects. I think this is something that actually is one of the more difficult things to conceptualize about your code. Oftentimes it's easy to use too few objects. I think there should be lots of objects in your code, especially if you're using a language like Java. Consider that with what a lot of people learn first. In fact, sort of what we're doing here, the way that we've got the code set up right now with a lot of methods acting one after the other. This would be called procedural programming or functional programming. The idea behind procedural programming or functional programming is that the functions are doing all of the work, and so anything that the functions need has to come in as input parameters and then get spit out as return values, and that's sort of the process of our programs. And almost everybody learns how to start programming that way, right? We introduce you to methods before objects. But objects are intended to kind of enhance the usage of methods, not remove their use. But the idea behind an object is we're going to abstract out pieces that are related to each other, kind of hide them, shield them under this object, and then we'll call methods upon those objects. Instead of passing in all of our data as parameters, the data that the methods are acting upon is stored in the objects as instance variables. So we're manipulating the data under the hood, but when we're calling those methods upon the object, we're not always aware of what the instance variables are or what's going on necessarily, and we don't have to. It's very similar to the act of driving a car, right? I know there's an engine in there that makes the car go vroom vroom, but I don't know how engines work very well. That's not my area of expertise, and I don't have to in order to operate the car. That is not a necessary thing for me to know, right? So this idea that I can have an object that does some complicated thing and just trust that it does that and not have to worry about the internals, not have to worry about the specifics, that's a very powerful tool. And then we also need to write our own objects with that in mind. So the idea of designing objects that meet that goal, meet that principle, is really what we're interested in talking about today. And so what you're going to see me do a lot of is get rid of this word right here, static. Is anybody familiar with what the difference is between static and non-static things in Java? Anybody already looked into it? Talk about it in 131 a little bit, but I know it's probably one of those topics that people still leave feeling pretty confused about. It's essentially just what I've described. When I call this method, I don't need an instance of an object to do it. I don't need to call a constructor. I don't need to get the instance of an object and call a method upon that instance. I just call the method directly. Or another way that we would say this is that this is a class level method. So static means that it's class level. It means that if I have a main method, which I thought I did somewhere. Yeah. The way that we're calling this method is more accurately probably described as dice dot. Notice how it's being called upon the class, as opposed to what we're going to do after we refactor this code. I'll hopefully show you. We're going to refactor out some objects. That's going to clean this code up a lot. And so what are the things that we're going to look for? What are the problems that we're going to try to use objects to solve? What are some flags you can look for in your own code for whether objects are designed properly or not? Some things to be aware of. That rule that I described to you last time, the rule of 20, says that no method should have more than 20 lines of code at the absolute most, preferably less, right? That rule applies to classes as well. Classes should not have more than 20 methods in them. So that's another application of the rule of 20. Classes should not have more than 20 instance variables in them. So, and again, the argument is not to fill up all of the classes until you hit that 20. It's preferably less. We wish to have small classes, very small classes that do very specific things, which means that we're going to have a lot of them. A lot of classes, a lot of objects. This is kind of counterintuitive to how I feel like a lot of people approach programming, especially in their classes. We actually do a lot of work within one class a lot of time, or maybe a couple. By the end of 131, we get you at least involved in 2 or 3 files. But really, in a professional project worked on by lots of people, there's going to be lots of them. Lots of small objects that do one thing and do it well. So that's kind of our goal. That's what we're looking for. It's going to help us reduce the number of parameters that we have. So this was something that I talked about last time, the fact that some of these have lots of parameters. I think you'll see that once we extract some objects out of here, we'll see that go down. We're going to kind of switch the way that we think about our code from a series of methods, a series of functions operating on some data, as opposed to calling those methods, telling these objects to perform some tasks for us on our behalf. All right, so let's try and look at this code and extract out some objects. I think there's, at least I hope there's one that's fairly obvious. Does anybody have an idea, or I probably even mentioned it last time in class, but does anybody have an idea of what we might look for to extract an object out of this class, or an idea for an object that you might have in this class? What's the part of speech that we use when I'm naming an object? Objects are always nouns. So I'm looking for nouns. I'm looking for things, right, that exist in my code. So what are the variables that I see represented here, and how often do I see them represented? I see I've got these tables and everything. Those are nouns, but actually, at the essence of all of this are the dice. So I think the dice themselves is a crucial object, a crucial part of this code. And we can extract out an object to allow us to represent the behavior of the dice and eliminate the need a lot of the repetition that we're going to see in this code. So let's do it. There's actually, unlike what I showed you last time, you know, with the fancy UI, there's not a lot of fancy things I can click on to make this happen. This is definitely a more conceptual, abstract thing that you're just going to have to think about and execute by creating classes and writing code and moving the code. This is what I'm about to do. I want to make sure we're on the same page, first of all, today, though. So I don't know if you have or have not been following along with the repository that I've been using in class, but if you have, the one that we used on the very first day of the clean code section, this naming repository, I just pushed a branch to it called functions24 that has the code that we did in class last time. So if you want to access that code, there's a couple ways that you can do it. If you're on the command line, make sure you're in the proper directory. Make sure you're in the proper directory of the repository, and then you should be able to check out the branch. And if that doesn't work, then you can also, of course, do a pull. Make sure you pull any changes first. It's going to give me error messages because I've already synced this branch up. The other thing you can do, of course, there's a way to do this in Eclipse as well. So I think it's fair to show you how you can switch branches in Eclipse too. Everything to do with Git's going to be in the team menu. So if you don't see the branch that you want to showing up here, then you just have to select new branch and then type in the name of the branch that you want, which in this case would be functions24, and then Eclipse will take care of checking out the branch for you and hopefully syncing up. You may still need to do a pull, which you can also do through the team menu by right-clicking and going to pull. And then, of course, if all else fails, then repositories are expendable. If I ever run into a problem with the repository and I don't feel like fixing it, then I'm probably just going to delete it and form it over again. Right? That's always a solution. Always a way you can fix things. All right. So I'm going to extract out this dice object, or this die object, a singular die, right? As an object I'm going to extract out. And I'll go ahead and create the new class. We have to think about, oops, don't need parentheses there. We have to think about what the instance variables are going to be and what the constructor is going to look like. With the, I don't know why I duplicated that. My brain is not fully online yet today. It's Monday morning. Sorry about that. What the instance variables are going to be and everything, and we want to be able to, I think, the code that we have over here assumes a 6-sided dice, right? But we can generalize that out if we want to and get rid of this magic number. This is the magic number right here. We're assuming that every dice has 6 sides on it. That's not true. Okay. Oops. Number of sides, we'll call that. Which means we probably need to accept that in as a parameter. Notice that I marked this private. Those of you who took 131 with me have already heard me make this speech probably, but all instance variables should be marked private. All instance variables should be marked private. There's two ways that we can access instance variables. We can just read them, see what the value is, or we can try to change them, try to modify what the value is. If we make things public, then that instance variable is fair game to everyone. It can be read, it can be written to, changed to whatever we want, whenever we want. That might seem convenient, but actually that's very dangerous, perhaps from the security perspective, but also just from a everything's working perspective, right? Because we don't want anybody to just be able to access those instance variables. So always, 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 our instance variables are going to be marked private. And if we need to provide access to them, we'll create getters and setters. That's what the purpose of getters and setters are. Getters allow us to read the value of that instance variable, and setters allow us to change or modify the value of that instance variable. And then kind of on the same lines, this is another good note for our topic today of objects. Sometimes students will get in the habit, and I get in the habit of doing this too, of just, once we've defined our object instance variables, just creating getters and setters for all of them, just for covering our bases in the future. I think that's a bad habit to get into. I actually prefer to not create the getters and setters until I have demonstrated a need for them, right? Hopefully, I don't have to provide access to this outside of the class. That's the safest thing to happen. Right? That's the most encapsulated thing. That's the most protected thing. That will keep everything hopefully working the smoothest, is if we don't let people mess with it. But if I have to provide access to it, if I have a demonstrated need, then yes, I can provide a getter or a setter. We may end up having to do that a little bit later on. To think about what this object needs to perform, I mean, this is a pretty simple object. We need to be able to roll it. Right? We need to be able to have it generate a value for us, which is based on the number of sides that it has. And so that's going to become our method. So if I roll the die, this will just be our math.random times the number of sides plus 1. Is that right? So if number of sides is 6, this will give me up to but not including 6, and then that would give me actually up to but not including 7, and then this would truncate the decimal point. I think that would work. We can test it out. We can write a little main method if we want to. Oh, well, so I'm getting ahead of myself. In order to test this out, we need to construct an object. So this is actually one of the things that we're going to have to go back in and do in the original code as well. Now that we have this object, we need to go back and construct this object. Calling the constructor, creating an instance of this object. In this case, we've been using 6-sided dice, so now I can tell it to call the roll method upon this object. Notice how using object-oriented programming, again, this actually accesses the instance variables that are within the object, but I can't tell that just by calling the method. I can't tell that those instance variables actually exist. I don't need to know. It also reduces the number of parameters. So if we had this as a static method by itself, there would have to be a number of sides parameter coming in. So it just helps clean the code up, keep the details out of here that don't need to be in here. I just want to test this and make sure that it's producing correct values. So there's a 4. I guess I could write a loop instead of doing this a bunch of times. It looks good. Okay, cool. So before I go back and try to insert my new object into here, I actually want to take a step and take a second to think if there's any other objects that we can extract out here. It gets tricky. It's tricky. We need to think about objects not in the physical sense sometimes. So a single die, that's a physical thing you can hold in your hand in your hand, right? A 6-sided die. But there are some nouns in here that exist that aren't physical things that you can hold in your hand necessarily, or you wouldn't think of them that way, perhaps. There's a noun that I see repeated over and over and over and over again, which is this right here. Throw. That's a noun, right? A throw. Yes, throwing the die is actually a verb. It could be used both ways, right? It could be a noun, it could be a verb. I think that if it's possible to express this should be an object. Should throw be an object? I mean, we can even experiment and think about what that would look like. Let's create a throw object. Let's create an object that represents a single throw. So what distinguishes a throw? A throw has many dice. So when I think about the instance variables that it contains, there's probably going to be some representation of the number of dice. It's also, I think, necessary, and this bothers me a little bit, although it might be okay. But having this additional piece of information, like we saw on the other one, how many sides we need, because the idea, I think, here is that we could, or maybe we don't actually. I'm changing my mind. Well, I'm going to leave it there and explain my thought process out loud as we go through. I think one thing that we can ultimately get to, though, hopefully, is that we can have a collection. So maybe I actually don't need this as an instance variable at all. Maybe what I actually need is an array of dice. Oh, it'll be an array of die, singular die. There we go. I think this works well. Because what this collection does is it allows us to actually keep track of both of those pieces of information that I was trying to think of before, the number of sides, the number of dice. So I can actually store both of those directly in that array instead of having to track them separately. It's going to keep all of those details where they need to be instead of having them duplicated all over the place. Let me show you what I mean by that. Instead of having them as instance variables, I'll accept them as parameters. The size of my array is going to be based on the number of throws that we have. Or, I'm sorry, that should be number of dice. Keep my terminology straight. And then once this is done, we actually have the additional step of constructing each one of these. When I create this array, what does it contain? After I execute this line, if I peek inside of that array, what would I see? If it was an array of ints, I would see zeros. If it was an array of strings, I would see empty strings. If it was an array of booleans, I'd see false. But this is an array of die, array of some kind of an object. So what am I going to see? What's the equivalent for an object? Starts with an N. Null. It's going to be all nulls. It's going to be all nulls in there. I've created spots where I can put objects, but I actually need to create those objects and put them in there. That's my responsibility as the programmer. So we can write a loop to go through this array and create them one at a time. And see how the parameter number of sides is being passed in as I create each die so that it knows how many sides that it has. I don't have to remember that information as an instance variable. That's just information I need to pass to an object so that that object can do its job. And now within this class, I actually think there's some interesting things that we can do. So if I want to, I can roll all of them, right? Do the whole throw, like that. And the fact that I have the die object makes it pretty simple for me to do that. So here I'm rolling the entire throw, which means all of the dice that it contains. We could use a loop for this. I actually think, a for each loop would be a better one in this situation. It lets us simplify the code like this. For every die that I'm keeping track of in my array, roll it. This isn't going to keep track of the value, though, right? I think this might show a weakness in the dice object for what I'm about to do next. Let me think about this for a second, because one of the things that we do in our original code that I'm sort of inching towards replicating is computing the sum of a throw, right? That was one of the methods that we extracted out. That's one of the methods that I think should go here within the throw object. In order to do that, though, I need to see what the value is on each of the dice. And there is not really a way to do that. The way that I wrote this code returns that as a value. But I'm trying to think of this as trying to mimic, real life. If I throw something on the table, like some dice on the table, they stay there, and then what I'm doing is I'm looking at whatever values face up. So maybe I need to have this code remember what that last value was that was rolled, right? Or the face-up value. Just keep track of that face-up value. I'm going to add another instance variable. Call it last rolled. And then I could return this, I suppose, but what I really want to make sure I do is store it to the instance variable. And this will allow me to create my first getter. I haven't created a single getter yet today, but I think I've demonstrated a need for one when I try to compute the, the sum. I'm going to have to go and ask each die in the dice array what the value is that it last rolled. So here's where I need a getter. I've demonstrated the need for a getter. I need to ask it what its last rolled value was. So let's go put in that getter. I could have Eclipse do it for me, but they're usually so easy to do. I'm using very long names for things, or trying to anyway. I don't need this main method anymore. That was just a little tester. There we go. Get last rolled value. And then what I'm doing is computing the sum. So we'll start that there. There. And then finally return the sum. All right. We've got two objects. I wanted to do this object before addressing the original code here because this object kind of includes the original die object that we had. And also, I'm glad I did that because there was sort of a hole in the design of my die object that I didn't like, that I fixed by adding another instance variable. That's not uncommon. What I would like to do now is revisit the original code and start trying to insert objects in here. We may find that there's another object we need to extract out. That could be possible. But I think we'll see how far we can go with what we've got. So if I look, starting at the main method, frequency table by calling this throw many times method. Okay. So let's go down to the throw many times method. It's constructing the frequency table and this roll tracker and these variables, right? Now for every throw, this code that computes and prints the sum, this entire line is actually going to be replaced with calls to the object. So we would construct a new throw with the number of dice and the number of sides, which were, that's still a magic number. I'm going to fix that at some point. That's going to bother me at some point. We'll roll it. And then the sum is just going to be compute sum. Is that? Oh yeah, that's what I called it. So I replaced that method call with these three lines that just utilize the new objects that we created. I suppose to keep things more accurate, I should call this what it used to be called, sum of throw. Oh, yeah, gotcha. There we go. I think the more important thing to keep in mind here, though, is that we've eliminated the need for this method to exist entirely, so the fun part of refactoring is blowing away the stuff that's no longer being used. Actually, yeah, this entire code as well. All of that is gone. All of that is now being done by our objects instead. For a lot less code, I would argue, as well. If you look at the code that exists in the die class and the throw class, a lot of it was duplicated, but the fact that we've abstracted that stuff out means that I don't have to pass the information from all the different methods all the way through like I was with the static methods. We're not even done yet. I think there's a lot more work that can be done to clean this code up even more. We still have this method here checking for Yahtzees. And when I look at this, I think, okay, where does this fit into my object design? Which object should be responsible for checking for Yahtzees? The Yahtzee takes place on what level? Does it take place on the singular die level or on the throw level when I got all of them? It's when I got all of them. It's when I have that whole collection. So this behavior, checking for Yahtzees, is really something that the throw should be able to tell me. After you've thrown the dice, it should be able to give me a thumbs up, this is a Yahtzee, or a thumbs down, this is not a Yahtzee. So let's write a method that can do that. It's going to return a Boolean, is Yahtzee. True if they're all the same, false if they aren't. Well, it's going to look very similar to this, just using our object code now. So instead of these ugly arrays that we're using, dice.length. I mean, we still have one array, but it's a single dimension. So this becomes dice. This also becomes dice. Boom. Yep. Cleans that up significantly. Allows us to come back and do a little bit more refactoring. This method, the way, again, this is a good review of something that I talked about at the beginning of class. The way that this method is written right now is as a static method. It's being called on the class, so even though it's not explicitly written out, it's implied that it's being called like this on the class. You can tell it's being called on the class because dice is a capital D, right? When I create instance of objects as sort them in variables, I use camel case in between systems. So there's this. So that's a big clue. With this capitalized, that's a static method. The italics is also telling me it's a static method. We want to get away from those. I actually don't want to see many of those on the project. I want to see good object design. I want to see good decisions about where methods should go in objects. And so we're going to replace this with a call to the method that we just wrote here. Notice there's no parameters, so it's going to look a lot more clean, a lot more straightforward. I already have a throw object that I can call this on called T, right? So I just call this and update that. And then that, again, eliminates the entire need for this method. I duplicated that behavior elsewhere. I don't need it anymore. So I'm actually really happy with the two objects that we've extracted out so far, die and throw. I think there's actually one more object that we need to talk about. It's another one that can be tricky to conceptualize, right? Well, let's look at the methods that we have remaining. Throw many times, right? Print frequencies. I'm talking about this class right here. This object, for starters, dice I think is a bad name. So anytime you see the name, yes, it is a noun, but it's a plural noun. So plural nouns are usually not great names. It's an indication that it's not a good candidate for an object. Consider that when I truly needed to have multiple dice, I had a name for that called throw that I could apply to that collection of dice, right? So just having a generic collection of dice is probably not a good idea. What we're actually doing is we're running some sort of a simulation here, right? So I would think of this entire original starting class as a dice simulator or a dice simulation. Because I changed the name of the class, I know some of you have already run into this from doing some of the other exercises and things that we've been working on. Because I changed the name of the class, it's actually required to change the name of the file as well. The name of the file in Java has to be exactly the same as the name of the class. If there's a mismatch, it won't work. So in order to change the name of the file, you'll have to right-click on it and go to Refactor. And now what I would like to do is figure out, okay, what instance variables does this thing have? I actually think one of them's right here, this frequency table. I think one thing that we can do is we can eliminate that magic number by making a constant. Right? Talked about this last time. Actually, I should mark this as final. That's another thing that we talked about in class last time. Could actually also make another one for the number of throws if I wanted to as well. And the number of dice for that matter too. And that way all of the parameters about the simulation that I may be interested in changing are located right at the top of the file. That's why it's a nice, consistent way of doing this. Now that I'm thinking about this as an object, it also is going to need a constructor. surprised I haven't given you this speech yet. It's one of my most favorite. The role of the constructor is to make sure all of the instance variables are initialized. The role of the constructor is to make sure that all of the instance variables have a value, are set properly, so that when we call the methods that exist later on down in the file, all of the instance variables are properly set. They're ready to do their job. They're ready to execute whatever things need to be executed. So the constants we don't need to worry about, right? We're going to use those here in just a second. The only real instance variable that we have to consider is this one. Make sure that this array is initialized and ready to go. How were we constructing that? As dice times 6? Okay. So, roll frequency table equals new int number of dice times 6. Now we're ready to start thinking about how these methods are going to change. I mean, ideally, what we would like to be able to do is just remove that word static. Again, I want these methods to be operating on the object as opposed to working as static methods. We're very much interested in using objects. So let's remove the word static from the two methods that I had remaining, print frequencies and throw many times. This one should be using our instance variable here, so we actually don't need this anymore. We'll just remove that because I think Eclipse is telling us that we're not using this roll tracker anymore. If you think about why that is the case, I've duplicated a lot of that functionality in the throws class, which contains an array of dice, right? So I think it's actually true that we don't need this anymore. It's not necessary. These two variables I think we do still need. Those are still doing work for us. Here you can see it's using our new instance variable, the roll frequency table. We shouldn't need to return this anymore. It's being stored in the class. So instead of returning it, we can just use a getter if we really need to, or this method here, right, instead of accepting this in as a parameter, can now just access it directly as the instance variable. So that's better. And then I think the only thing that we have left to do is to take a look at the main method. We've created this dice simulator object. So let's create an instance of it. Instead of calling the methods like this, the static way, I'll call them this way. We can use our constants here. That's what they're for. Number of dice, number of throws. Why are you unhappy about that? Oh, interesting. Did I get too clever? I may have gotten too clever. I'm glad that this happened though, because I can explain this error message. It's actually a recurring theme that we've had today. This difference between static and non-static things. This is a good illustration of what can happen. It's getting mad because I'm trying to access this value, even though it hasn't been declared as static. So when I declare instance variables like this, that means that every instance of an object has its own unique copy of that value. That's what that means. And so static methods are not able to access them because static methods exist for all copies. They exist for all copies of the class. That's another way of saying that they're class level. But what that can be done in, what you can use that information for in practice is to help you distinguish whether you need a method to be static or not. If you're trying to decide, should I mark this method as static or not, just see if it's accessing any instance variables. If it's accessing instance variables, then chances are it does not need to be static. Instance variables can be static as well, though. And so, you know, one solution to this problem is to do that. I actually don't think this is necessarily a bad solution. If it's asking you to make your method static, so one thing that I can see, and I imagine I probably will see, because I see it almost every semester on the project, Eclipse will make the suggestion to fix this problem by having you start switching methods into static methods. It's trying to help. It's trying to make a suggestion. That's actually what we want to get away from. I want to avoid using static methods. Marking constants as static is actually not a bad thing. That means that all instances of the class will be seeing the same value. But anyhow, to get back to the final task at hand, I think we've removed the need for that, and this method call is now being called on the object. Okay. This variable is going to get used here to get rid of that magic number that I was upset about. Beautiful. All right. I know I did a lot there. I kind of went on several tangents. I probably lost some of you at some point along the way. I understand all of that. I am done refactoring this, though, so if anybody would like me to go back over any parts of it, yeah. Did I? Yeah, that's what I've labeled it as. Well, so this one right here, yes. There you go. Thank you. Is that what you were talking about? Yeah. Good catch. That was another magic number that I needed to fix. Yep. So, just to kind of go over this again from a general perspective, I will commit and push this code to the repository too, so that you all can take a look at this more after class. This is a great example of, I mean, it's a good example of how to find objects and extract them out. Real examples are probably not going to be as, you know, easy. I guess. What am I trying to say? It really is so dependent on the context that it's hard to give concrete rules about how things should be done in every particular situation. So while I've given you some rules of thumb, like, you know, rule of 20, when to make constants, when to mark things static or non-static, every single method you write is going to be one of those judgment calls, right? And there may not always be a strictly correct or incorrect answer. I think too, a lot of what I'm hoping you'll see is that if we can write, you know, our methods a little bit shorter and more clean in the first place, that it really helps keep things. I mean, compared to what we started with, this method has undergone quite the transformation, right? In fact, I think some people might even argue that we could extract even more methods out of this, perhaps. The overall quantity of code is bigger, though, which is an argument that some people will make. It's like, yes, I guess it's cleaner, right? It's more sectioned off, but it's actually bigger. And to that I say, well, organization requires space, right? Organization requires sectioning things off in their own compartments. That takes space. So if that's what you're concerned about, yes, your code is going to get a little bigger. But our goal is not to make things as short as possible. Our goal is to make things easy to understand while still functioning and working well. So with that in mind, I want to talk about some more rules to consider with your objects. And we'll wrap up with a discussion about the homework assignment. I've already mentioned the rule of 20, which is, again, fewer than 20 or fewer instance variables. These are very small objects, which is great. I like that there are a few variables. I like that there are a few methods. The organization of your class matters. Notice the constructor is always at the top. The methods come after that. If I have private methods, which I didn't really use much of today, they would typically come after my public methods. Instance variables, always, always, always at the top. Always, right? Some other things to keep in mind. Some ways to know if you are or are not using enough objects in your code. There's something called, I'm going to write this out because I think it's important for you to see. The law of Demeter. This is just a rule that you can apply to any class to see if it is using objects appropriately, or if there's maybe some room to approach the design of the objects and clean it up a little bit. If I'm in a method, or if I'm in a class, right? So there's a class called C, some generic class called C that contains a method called F, right? Here's what this would look like. The law of Demeter says the only methods that should be called are from C, so any methods that are in the class that I'm currently in, or in other words, this dot, objects created within F, the current method. So what that means is if I create an object within this method, right, I can call methods upon this object that was created. That's an acceptable piece of behavior. This is okay. Objects passed as arguments to F. So if I have an object passed in as an argument, as a parameter to this method, then that's okay. That's an okay method to call. Call a method upon that. And then the last one is an object held in an instance variable of C, the current class. So what that would look like would be this dot D, where D is, you know, some instance variable, right? That is an object dot role. And you might think, well, okay, like these seem like pretty broad categories of things. What are some examples of method calls that would not be okay under this law of Demeter? We're trying to avoid something that is sometimes called chaining, for big chains. So using dot notation, right, is a very convenient thing, but we can overdo it. We can certainly, and maybe you've written statements like this where it's, you know, you're like d dot x dot y dot z dot, right, dot do the thing. This is what we're trying to avoid, right? Statements where I'm chaining together so many things with dots. I should not have to go that many levels deep to find the behavior that I'm looking for. That's a sign that there's at least one object in there that, you know, it's not doing its job properly or doesn't exist yet, needs to be extracted out and turned into a class like we did today. we're really trying to keep the methods that are being called local. So only objects that are being created within the method, passed into the method, or very easily accessible by the method are the ones that we're going to call objects upon. I mean, in practice, it's not usually that bad. It's usually as simple as looking for a couple of dots, right? If I am using, I mean, the rule again is to say, if I'm using more than 2, maybe 3 dots to chain together a statement in Java, I'm reaching too far. Away. Another thing to keep in mind is one thing that was not on the list. If I get an object back as a return value, so right. This was not on the list. So calling methods upon this, no, kick it out. You've already done some work here. The idea is that we're gonna maybe return this object as the end result and let that object do some work somewhere else. The result of strictly following the law of Demeter leads to more methods, actually, more objects. And I want to try and convince you that that's a good thing. We want lots of objects. We want lots of methods. Well, we don't want lots of methods within reason. We want to keep it to 20 or less, but well-designed objects where the behaviors contained within accurately define what that object is doing. All right. Any questions before I switch over and talk about the assignment? I think what I'm going to do before I forget is actually I'll just commit and push this right now and get rid of that because that's broken. Get rid of this. Refactoring out objects. Okay, so I've pushed those changes to the GitHub repo. If you want to take a look at them, you're more than welcome to. Again, this is something that you're going to be tasked with thinking about on the project. So do I expect you to get all this stuff right the first time? No. But after we go through the first peer review, if you get feedback that says, oh, I think you need more objects here, well, okay. The next time around, I expect you to figure that out. Figure out how to make it work. It's a skill. You need practice. It's going to feel weird the first few times you do it. I do have a homework assignment to help you practice these skills, though. So to kind of wrap up our clean coding section, we get to do a little bit of self-reflection on our past work. So assignment 5 should hopefully be a very personal one for you. I get good feedback about assignment 5 every semester. Well, good and bad, I guess. People tend to really like this one, or maybe not so much, depending on your past coding experience. You're going to go find an assignment from the past class and clean it up using the rules that we talked about in the last few class sessions. So we focused on 3 areas in particular: naming, methods, and objects. So I want you to go find an assignment from the past, preferably in Java, which I know does limit things, although I know other languages. I guess for this assignment it doesn't actually have to be. It does say Java. Yeah, it does say Java. So probably should stick to that. We've been using Java all semester. Never going to switch now. But and then clean it up using the rules. And then I also want you to provide a little write-up. Please make sure that you address all 3 areas. So I want to hear you say things about naming, methods, and objects within the code selection that you've picked. I understand that maybe you don't have any issues with the way the variables are named in your assignment. Maybe you think you did a good job back then, and you just want to focus on the methods and the objects. That's okay. You still need to say that. Right? You still need to justify. I didn't change any variable names because I thought they were good already. Okay. You better hope that's true. So I'm going to look at them and see, right? And see if they're actually descriptive and good enough. Sometimes students do struggle finding an appropriate assignment from the past that they can use. I mean, Virtually any assignment from 131 would be acceptable. 247 I know is also done in Java. There's that's another common class that students choose to draw material from. So it can really be anything, but if you're having a hard time thinking of an assignment or finding an assignment from a past class that you want to use to clean up for this assignment, you have another option, which is to choose an open source piece of Java code, which of which there are plenty. GitHub has the ability to search by language. So if you want to go find Java repositories, right, on GitHub, that's as easy as telling GitHub you want to find what language you're interested in, and here you go. Here's a whole bunch of them. There are plenty to choose from, and I guarantee that you'll be able to find some not necessarily good code in here with which to clean up. Which is, on a related note, I am interested in open source projects. I've created open source projects, I've contributed to open source projects, so I always like leaning on open source stuff when it's possible to do so. I think it's great that you have the ability to use it as an assignment. If you're new to it, it can seem kind of intimidating, so if you're struggling, reach out to me. I can help you out. I can help you find something that's suitable. I do think it's I'm not going to deny that it can be a little tricky to find a suitable Java class for this assignment, but it's not impossible. Definitely, I have some ideas that I can kick your way if you're really stuck on finding something. But I would like for you to take a look and see what you can dig up yourself. Minecraft is written in Java. I don't know, although it's not open source. I think older versions of it are. I've had students dig up old versions of Minecraft and submit those in past semesters as one common example. Yeah, that is the main task. And so then to submit this, you're going to need to submit a few different pieces. I need to see the original code, uncleaned up, right? And I need to see the cleaned up code. And then I also need a little write-up. It says 1 to 2 pages. I'm not a super stickler on that, right? If you come in at 3/4 of a page, when you say what you need to say, then cool. Happy for you. If you want to create a repository for your code and dump a link to the repo in your write-up, that's cool. Sometimes that can be better than trying to copy and paste code into Microsoft Word, which is an absolutely terrible thing to try and do. If you've tried to do that, that does not work very well. So I discourage you from trying to use Word for code writing purposes or code purposes. For doing the write-up, sure, but you may want to consider just using text files or even submitting the Java files, right? Just submit the Java files directly. It's fine with me. Don't have a problem with that at all. And then just keeping the write-up in Word so that you don't have to mix the code together necessarily. Does anybody have any questions about the assignment or anything else that we've gone through today? I also meant to ask about assignment 4. Does anybody have any questions about the unit testing stuff? No, I talked to some people about it. It seemed like it was going okay. All right, I'm going to go ahead and wrap it up. If you have questions about assignment 4, which is due today, I'll stick around and chat with you. Otherwise, I'll see you on Wednesday. Have a good rest of your week. Question?
If I happen to be doing code assignment 4 and it is super far away, is there any like buffer like save our locally or anything like that? I mean, it wasn't